These are a few solutions to the slope fields worksheet, the 0-2 homework. So question 1 asks us to draw a slope field for each of the following differential equations. Well, a slope field can be drawn by just making slope segments by substituting in x and y coordinates. So for example, if I plug in x equals 0, I get a slope of 1. So at 0, 1, 0, 2, 0, 0, 0, -1. So the y coordinate doesn't actually affect the slope here. Okay, so if I plug in x is -1, I get a slope of 0 here, 0, 0, 0 slope, 0 slope. -2, I get a slope of -1, -1, -1, -1. -3 will give me a little bit steeper slope. So slope of -2. Here x is 1, y is 2, so I get a slightly steeper slope here. So slope of 2, 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 a slope of 3, etc. So this is just going to give me increasingly steeper slopes as I go from left to right. Okay, and we can see that the y value does not affect the slope here. In fact, if we anti-differentiate this, we'll get a quadratic function. For this one here, the x value shouldn't affect the slope. So if I just choose a y value, if I y at 0, I'm going to have slopes of 0. So I draw my slope segments here. At y equals 1, I have slope of 2. And the x value won't affect the slope. At y equals -1, I have -2, so it's going to slope like this. And at y equals 2, I get slopes of 4, so it's even steeper like this. Okay, so the same thing happens here. Y is -2, I just get even steeper. So it looks like it's kind of bending away from the middle. This one's a little bit harder, but if we take a look at this graph, x plus y, okay, well I just start at 0, 0, I'm going to get a slope of 0. And in fact, if x is 1, y is -1, I'm going to get a slope of 0. And what ends up happening is along this line, I just get 0 slope. So -2, +2, they cancel out, I get a slope of 0. At x equals 1, y equals 0, I'm going to get a slope of 1. At y equals 1, x equals 0, I get a slope of 1. In fact, along this diagonal line here, at 2, -1, 3, -2, I end up with slopes of 1. And then at 2, y is going to be 2 and 0. 1 and 1 is going to give me a slope of 2. 2 and 0 is going to give me a slope of 2. So everything, basically anything along these diagonals are going to match the slope. So it's just going to get increasingly steeper as I draw it like this. Here at -1, y is 0, x is -1, I get a negative slope like this. In fact, these are all -1 slopes. In fact, they're just kind of pointing at each other. At -2, 0, I get a slope of -2. Okay, a little bit steeper, and then again along this diagonal I'm going to have these slopes like this. It's going to be even steeper through here, -3, -4. Okay, so I get this graph that kind of looks like it's bending like this and bending away like this. If y equals 2x, right, the antiderivatives of this will be x squared. So if I were to draw this, your slope field should look like a parabola. So you can do these on your own. We'll take a look at a few other ones here. So this is asking us to match the slope field with the equations. So taking a look at these slope fields and taking a look at the equations, maybe we'll just try to match some of these equations. So looking at question number 7, y equals 1. Well, y equals 1 is a horizontal line. Well, the only one that has horizontal lines for the throughout is going to be this. So that's going to be y equals 1. For y equals x, it's just going to look for diagonal lines sloping to the right. Well, this one here, just by visually inspecting it, I can see that that's going to be y equals x. For number 9, y equals x squared, looking at these, I can kind of see that this is, if I look at the shape of this, if I follow the slope fields, it's looking like a bunch of u's. So this must be the parabola. This is going to be x squared. X cubed, 1 over 6 x cubed. Well, this one looks like it's going up and down too much. This one does not look like a cubic. The cubic function looks like it's going to be this one here. Okay, so this is going to end up being y equals 1 over 6 x cubed. And I can see that it's just a cubic function sliding through there like that. For number 11, 1 over x squared, it should be a reciprocal function. And it should have a horizontal asymptote. And it should also be, looks like we should have kind of positive slopes on one part, maybe a negative slope. So this is going to be 1 over x squared is going to be a horizontal asymptote, and then as x goes to 0, as x goes to positive, negative, infinity, it'll give us a horizontal asymptote, but it's going to go up, right? This is going to always be positive, so it's going to go in the positive direction, so this one should be 11 here. Okay, so that we could maybe mistake it for this, but this is going down, pointing down the asymptote, whereas we need this to be pointing up the asymptote. For y equals sine x, this one here looks like our sine graph. It's going, the max min is not through the 0, which is what we would expect for the cosine. So this should be number 12. So this is y equals sine x. And then this similar shape here, where the max goes through 0, this should be our cosine graph. So y equals cosine x. And lastly, this will be the log x absolute value. The log function looks like this. The absolute value makes sure that it's mirrored on both sides. So number 14, this is y equals log x. For these ones here, we can match the slope fields with the differential equations. If I take a look at this is a circle, and I kind of know that this is the derivative for a circle, but I can just double check. I can just check, at x equals 0, all the x equals 0 coordinates are going to give me a horizontal slope. All the y equals 0 coordinates look like they're giving me vertical slope, so that looks like it's fairly consistent. And if I just test one point, 1, 1, negative 1 over 1 is going to be that slope there, so it checks out. So this is going to be dy by dx is equal to negative x over y. For b, this looks like a parabola, and I can kind of guess that this is probably going to be 15, but I can double check again. This is, I can check a point at x equals negative 2, the slope will be 0. Yeah, negative 2, slope is 0. That seems to be correct. And it's independent of the y, so all this negative 2 coordinates give me slopes of 0. Any numbers this side will give me positive values. Every numbers this side will give me negative values. Yeah, I see positive slopes and negative slopes. And it does look like a quadratic. So this dy by dx looks like it's going to be the linear function to x 1/2 x plus 1. And if I anti-differentiate this, I'm going to get x squared plus x, which is a horizontal shift to the left. Here, the y value is going to determine the slope. So if I take a look at any of these, this is the only one where the y value, the slopes along that line, is going to be all the same. All these slope segments are all exactly the same through that. So all these y values give me the same slope. So this is dy by dx is equal to y. Okay, and again, I can test some slope coordinates at y equals 1, slope of 1, y equals 2. If I go in the negative, I get negative slopes. And so lastly, 17 should be this one here, but we should test this. X minus y. Okay, so x minus y. That means when x and y are equal, we should have 0 slope. And in fact, x and y are equal along this line, and we have 0 slopes along that line. when x is 1 bigger than y, so 1, 0, 2, 1, 3, 2, etc., along this line, all the slopes are going to be equal to 1. And along any diagonal line here, we're going to get the same slope because all those terms we're going to have an x minus y that's constant. And I can see that, yeah, along here, along these diagonal lines, it looks like we're going to have the same slope. And again, if I'm not sure, I can double check a few more points. At x equals 2, y equals 0, x equals 2, y equals 0, I have a slope of 2. Yeah, that looks like it's going to match my derivative. So dy by dx is equal to x minus y. So lastly here, we want to be able to draw our equations through slope fields. So here we have the slope field, and our solution to this differential equation is going to be one of these lines that follows the slope field. So if I start at 0, 1, 0, 1 there, if I follow the slope lines, I get this black curve. If I do the same thing at 0, 2, that point right there, if I follow the slope lines, I get this shape. Okay, if at 0, -1, that means I'm starting here. If I follow the slope lines through that, it looks like it's going to kind of follow like that. Okay, so that's going to be my graph through that slope field. And the same thing can be done here. And we can see that at 0 and 1, so that point right there, it's going to be pointing up towards this slope field like that. It's going to point across, and then it's going to point along this like that. So it looks like it's going to look like that. So that's our point starting at 0, 1. If I start a point somewhere else, for example, -3, 0, so 1, 2, 3, -3, 0 is right there. If I were to follow the slope field, it looks like it's going to follow this kind of shape here. And they both look like they have an asymptote along that line. So these are some selected solutions, so make sure that you try these on your own, but you can check some of these over in the video.